Okay guys, welcome back for this instructive video on the mean value theorem. So this is a pretty exciting thing. One time I was asked in an interview what my favorite theorem was, and I said the mean value theorem, and I got the job. So I think it's worth knowing about. So here's kind of the hook and the idea. If I'm driving my car and I get on the freeway and I drive for 1 hour, and in that hour I drive exactly 70 miles, does there have to be a point in time where my speed was exactly 70 miles per hour? So if over that 1 hour period, I traveled a total of 70 miles, was there one time in that hour when I was going exactly 70? And the answer to this question is yes. The mean value theorem is what guarantees that. So here's what the mean value theorem says. It says if f is differentiable, so didn't we just learn that word? So if f is differentiable and continuous on some interval a comma b. So this is the condition, right? So if you have a function that is differentiable and continuous on some interval, then there's got to be some conclusion. Then something else has to be true. And the conclusion is that there must be a value x equals c with f prime of that c equaling f of b minus f of a divided by b minus a. So there has to be some point where the instantaneous rate at that point is equal to the average rate of change on that interval. So in terms of like lines, this is saying there's some point where the slope of the tangent line, that derivative, is equal to the slope of the secant line between the two endpoints. So graphically what that's saying is if you have some A and some B, and you have some graph, and I don't know, it like does something that looks like this, whatever. So it goes from this point to this point here. The average is right there. That's my average rate of change, the f of b minus f a over b minus a. The mean value theorem guarantees that as long as this function is differentiable, there has to be somewhere in the middle, not the exact middle, but somewhere between a and b, there's got to be some point with the tangent line at that point with the exact same slope equal to that average slope. That's what the mean value theorem guarantees. Okay, now one thing I want to note, this obviously must be differentiable. If it's not differentiable, you can see there's going to be some very clear ways around this, right? Because if you could just have like a V-shaped graph, and there's no point in the middle where you have a slope of 0, right? So there's no point with a slope of 0. So that's why the idea of differentiability is so important. If it's differentiable, we know we can use the mean value theorem. Okay, so let's get to a couple of examples here of different types of problems. So you might see this. So you might see, find the C that satisfies the mean value theorem for f equals x squared plus 2x minus 5 on the interval from 0 to 2. Okay, so when they give you this problem, like obviously this is my a and this is my b and here's my function, what they're telling us is we're trying to find the value of c with f prime of c equaling f of b minus f of a over b minus a. Okay, so what you're going to need to do is you're going to need to take the derivative and you're going to need to set it equal to this average rate. And then once you have that, that's going to give you a way to solve for that x. So we're trying to see what is the point where the slope is equal to that average slope between. Okay, so there's my f. We know it's a differentiable function, so we know we can use the mean value theorem. So my derivative is 2x plus 2. And then when we're trying to find the average rate of change here, right, like f of 0 is negative 5, f of 2 is 2 squared, so we have 4 plus 4 minus 5 is 3. So f of b minus f of a is 3 minus 5 over 2 minus 0. So that's telling me that 2x plus 2 equals 8 over 2, or 4, of course. So 2x is equal to 2, so my x value turns out to be 1. Okay, so what that means is that is the point where the slope at that point is equal to the average rate. So if you have this parabola, it's saying that, okay, like in between here, we have some slope, and we just found, so like this is 0, this is 2, we just found the point in the middle that has that same slope, has a parallel slope. That's what we're doing. Okay, let's do another one then. So same thing, we're going to find the C that satisfies this MVT, this mean value theorem, for y equals ln of x plus 1 on the interval from 0 to 3. Okay, so again, that's my A, that's my B. So we're trying to see where does my f prime equal f of 3 minus f of 0 over 3 minus 0. The mean value theorem just tells you that there has to be a point, and our goal is to find that x value where we do have that average rate. So the derivative of this is 1 over x plus 1 times derivative times 1. F of 3 is the natural log of 4. F of 1 is the natural log of 1, which is just 0. That worked out nicely. So this is just equal to ln of 4 minus 0 over 3. So that's saying 1 over x plus 1 equals ln of 4 over 3. And we can cross multiply this guy. So we're going to get 3 equals x plus 1 times ln of 4. If you have to solve something like this, probably just divide the ln 4. So 3 ln 4 equals x plus 1. And then you just subtract. So 3 over ln 4 minus 1. Okay, and there we go. So that's how you solve it, right? You're taking the derivative, you're setting the derivative equal to, again, this average rate between the endpoints. That's that type of problem. There's some other problems as well. And one thing I want to point out, here's kind of a note. So if f of A equals f of B, and again, your function is differentiable, one consequence of the mean value theorem is this. There must be a C with the derivative of that C, so f prime of C, equaling f of B minus f of A over B minus A. But if f of A equals f of B, that's just equal to 0, right? Because the top, these two terms are identical. So this is saying if you start and end at the same point, so if they have the same values for A and B, there's got to be some point in the middle with a slope of 0. If you go up, you got to turn around, basically, and that's where they get you. Okay, so here is an example. So I'm going to tell you that g is a differentiable function. You'll see that a lot in problems. G is differentiable. And then we're going to give you a table of g values. So x goes 0, 3, 4, 6, 7, 9, 10. And then the values here are 2, 4, 5, 2, 0, negative 1, 0. Okay. And this question is going to ask you this. At least, how many times must, that's not an M, must g prime of x equal 0 on the interval 0 to 10? And then, of course, y. So the way you're going to answer this question is thinking back to like this corollary here, that if we have an equal value at 2 points, there has to be a point in the middle where the slope is 0. So here's how you want to write this up. First off, I'm going to look for any g values that are equal. So I see like, okay, a 2 and a 2. It goes up and then it goes down to 2. And then it goes down to 0 to negative 1 and then back to 0. So I see 2 points there. So the way I want to write this up is, okay, I see this as twice. Since my g is differentiable, and when you're doing any problem with the mean value theorem, you always want to cite that. You always want to make sure you write that you have a differentiable function. They are going to be looking for that on the AP test. So since g is differentiable, there must be a c on the interval 0 to 6 with g prime of that c equaling g of 6 minus g of 0 over 6 minus 0, which is just 0. Okay. And then also on the interval from 7 to 10, so there must be a c with g prime of that c equaling g of 10 minus g of 7 over 10 minus 7, which in this case is still 0 because those values are the same, so at least twice. So when you're writing these up, the key things that you need to make sure you have. You need to make sure you mention that g is differentiable. You also need to talk about the intervals. So you got to say, okay, once on 0 to 6 and once on 7 to 10. There has to be a point on each of those because that's in the graph where we see we have the same values here. Okay, so I wanted to do one more little thing relating to this table. So let me just copy this over. Okay, so using this same table now. Oh, that like almost looked good. Okay, so using this same table, now suppose I asked you, does there have to be a point? Does there have to be a point with a g prime equaling -3/2 on the interval from 0 to 10? Okay, and the way you want to do this is you would like to actually just look at each interval. So look between each points and then find the slope and see if there's ever a point where we have a slope of -3/2. Okay, so on here, like remember when I do slope, I do y minus y over x minus x. So 4 minus 2 over 3 minus 0. So that's a 2/3. Here we have a slope of, let's see, it goes up 1 or 1. Okay, that doesn't work. Here we have a slope. It goes down 3. Oh, ding, 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 ding. Ah, we did it. Okay, right there on 4 to 6. So we can say on the interval from 4 to 6, since g is differentiable, there is a c with that g prime equaling your g of 6 minus your g of 4 over 6 minus 4, which in this case is -3/2. So again, I'm citing the fact that it's a differentiable function. I'm showing the interval. I'm showing where I got that value from. Okay, so that's the mean value theorem. It's very powerful. I want to show you one more cool thing here. So if you take a look, in GINA, there's actually a bridge with the mean value theorem on it. Like I know they use like this epsilon right here instead of a C, but it's just the mean value theorem and they put it on a bridge. Why don't we have something cool like that here? Okay, thanks for watching, guys, and I'll see you guys soon.